Hello everyone and welcome to today's live stream where I have very exciting news. The instance bounds node is now inside of Blender 4.5. The daily build you can go and download it right now, but it is officially part of Blender, which I'm very happy about. I need to thank the devs because this node was a lot more complex than I originally thought it was going to be, and they helped me out a lot with it, but now that it's here, it's working quite well. So, what does this node do? Well, basically, if you have an instance, it'll tell you the min and max bounds of that instance, by evaluating the root geometry rather than just having to calculate it for all of them. So in the past, this is what we would use as the workaround. Now this workaround, as you can imagine, wasn't all too great. Let me do a quick demonstration of the logic. But here we would go and use the bounding box node, which, let me disable the viewer, there we go. Which would physically, it would go and change the instances themselves into cubes, and then you would store the data, then sample the data and all this, which was, it would accomplish the goal, but it was slow and rather tedious to set up, as we can see here. But now that we have this alternative, make sure that's set to instance, it's now just one node. So it goes on all the top level instances and just calculates the bounds, which is very nice. There was a version of this node that did like calculate the bounds recursively, but unfortunately we couldn't do that because it would modify the instances, which I did not know was even possible, that an input node would modify the geometry like that, but apparently that was possible. So it's only the top level instances, but that's to be expected with this kind of input. So yeah, all of this is now available. So what are the practical applications? Well, let's do something very, very simple. Let's use a set position node and make it so that all of these instances are just, let's see, at ground level. So here we'll just do this, make it so that it's just like that. So all these are on the ground level, but what if we want them to, you know, be aligned with their bottommost part? So right here, we can do a very simple, put in the min into the offset, but I think we need to scale this by -1. Let me delete the frame, just so that we can make this very nice. So here, if we just set that to be -1 and plug this into there, as we can see, all these are now aligned. Like, they will actually just align with the floor plane right here, which is very nice. Now, technically, you want to make it so that only the z-axis is taken into account, but as we can see here, it's pretty nice. If you want it so that it's the other way around, just put in the max, and we can see that works out quite well. Now, rotations aren't taken, rotations aren't taken into account when the bounds are calculated, which that is intended behavior. So over here, we can see that these are a little bit off, but that's just because, again, that is 100% intended behavior, because it gets the bounds of the root geometry rather than just like the current transform, which is the same as the old workaround. So yes, other things that we can do. Let's go and delete all that. We can go and stack instances just like this. So as we can see here, we just get the instance bounds, subtract the min from the max. I think that's accurate, or it needs to be reversed. Wait a minute. Yeah, that seems to be a bit more accurate. You subtract the min from the max, and then you accumulate field, you add the leading to the trailing, and then you multiply it by 0.5, put it into the position, and as we can see, all these instances are stacked accordingly and perfectly, which is very, very nice. Like if you had like a book stacking kind of thing, it will automatically stack them. And the performance is much better than the alternative. So let's go and do a quick performance check on this. So let's use a duplicate elements node. There we go. And we'll set this to be around 25. So we have 25 instances, but we can't really see them because they're all overlaid on top of each other. Let's use the random info node to make it so that they're all like that. So that's be -1. There we go. So now let's go and compare the instance bounds node, and let's use a capture attribute? No, let's use a store named attribute just to have a nice reference here. So this will be instance. I'll just label it A. So here we will store the min, and we can see that takes less than a millisecond. Yep, less than a millisecond to calculate the bounds for all of these. Now let me just go and verify that this is actually working as intended. This needs to be instance, that needs to be, whoa. Oh, wait. I think that might have been the incomplete stream key, which is very good that, yeah, that was cropped. Yes, that could have been bad. But yeah, as we can see here, all that gets calculated, and it is very, very fast. So now, yep, and that part works well. But if we were to use the current workaround, or the old workaround, I need to rename that, we will see that this takes quite a bit longer. So we can see that storing it takes the same amount, but calculating it takes 1.2 milliseconds. So let's go and up the amount here just so that we can try this on something that's a little more intense. You can see that takes 2.5 milliseconds, and with the old version, again, it takes 0.1. So that is a big time savings. And the efficiency becomes greater and greater the more instances you have, even if they all share the, or no, even if they don't share the same geometry sets. So I could try that out, but that may be very expensive to calculate. How many instances do we have here? Let's see, we have just a few. Oh, whoa. Why is it lag city at the moment? Okay, that seems to have fixed it. So if we were to realize the instances to make sure that they're all original geometry, and then set this to be 2 instances. So we're basically, all we're doing right here is converting it to unique instances with unique geometry sets. Let's get the mesh island. Oh, nope. The mesh island. There we go. I'm going to set this to 50 so that it doesn't lag too much. Okay, so we can see that that takes 600 milliseconds, which is not great. So I'm going to use the bake node to bake that beforehand so that it does not calculate. There we go. So all that's stored and we don't need to worry about that. So if we use, yeah, let's go and do that. Use this node and take a look at the output. We can see that it takes 2.6 milliseconds. Now, if we were to try that with the old version, let's take a quick look at that. We should see that this becomes a lot more expensive. 39 milliseconds. So 39 milliseconds or 2.6 milliseconds, which is very nice in the savings department. And how many instances was, oh god. Let's just wait for it to calculate. Oh, it is having trouble. Shouldn't be having that much trouble, right? Well, let's just wait and hope it does not crash. But yeah, a new node in geometry nodes, which is quite nice. I think Blender may have crashed because of how resource intensive the guaranteeing... Oh, yep, no, it just straight up crashed. Please, that is not a fault of the instance bounds node. That's just... Oh god. My entire... End process, please. Okay. Are we back? Oh my god, I think we're back. So anyway... task manager. So anyway, that was not the fault of the instance bounds node. That was because for some reason, realizing all those instances just caused it to have a grand breakdown. So, how about that? But yeah, since we're back in action, we can see that once again, everything is working as intended. Stacking is working very nicely. And then what else? This would be the old workarounds now. There we go. Very, very nice. But yeah, new node. I'm very excited about that. So that's 2 nodes that I have worked on with quite a bit of help with, from the Blender developers. That is now in Blender 4.5. There's one more node that I plan on working on, which I hope I can figure out in time for the beta, but I am not entirely sure, and that is the scene info node, which will just give you some general scene information like the start frame to end frame, the scene gravity, the resolution, X and Y, the aspect. So that could be useful. So I do hope to get that into 4.5, but no promises, just because, one, I got a lot going on in the upcoming weeks, and the dependency graph is notoriously annoying to work with in my experience. I will try to get that done. And then also there's another constraint that I'm trying to figure out and working on. But that could also be interesting. Probably not for 4.5 though, but maybe a miracle will happen. We will see. But yes, the old workaround is done, and that is like that. You are unstoppable? No, I am extremely stoppable in this case. Mainly because, like, I've run into many roadblocks, which fortunately the Blender developers have been very, very helpful and very accommodating for my lack of C++ and Blender codebase knowledge. But yes, the nodes are good. I wanted these nodes, like the instance bounds node I plan to use for camera culling, which I hope I can make that work. It'll be a little bit complicated to make the instance bounds, like calculate that and then or get the instance bounds and then you properly project that with the camera frustrum. Actually, we can do that today. So bear with me while I go and open up that file. Let's see. Okay, so this should be the file. So this is a camera culling node made with the previous node that I partly coded for Blender 4.5, the camera info node. So now, yes, here are the 2 nodes that I have worked on. Instance bounds. There we go. So these 2 is very, very nice. So using the instance bounds, I could potentially make it so that instances that are bigger properly occlude with the camera frustrum, or frustrum? I forget how it's pronounced. And then ones that are smaller don't get culled too far away. Now, is this strictly necessary? I'm honestly not too sure, because you could just go and like do that and you should be fine. But having the option is probably a good idea. So the question is, how would this be done? Oh, and by the way, this file is up on my Gumroad page for free. Link should be in the description. So yeah, if you want to just pick this up and use this in your Blender 4.5 scenes, it would be good. It's very useful for, like, if you have tons of foliage that you don't want to appear all at once. That could be very resource intensive. Trust me, I know I've had many opportunities for a node like this. But anyway, let's see, instance bounds, yeah. So how would we do this properly? Well, we would have to take the max and subtract the min. And then that would give us the total length of it. But we would also need to take into account the origin points, which is just the average of the 2. So, ooh, yeah, no, this is, I would probably have to look up how to do this properly. Because not only do we need to calculate the bounds of all these instances, we also need to scale them according to the current scale, but actually that's not too bad. The main thing is just taking into account the distance from the camera and then doing that. And then incorporating that into the distance calculation right here, or the distance from the camera frustrum. That is going to be so incredibly annoying that I think it would be best if I didn't do it on stream. Yeah. I guess we could use the instance bounds node to go and, let's see, to make sure all these spheres are not clipping into the ground. So instance bounds, let's go and use the minimum, use a vector path multiply, set the z to be -1 and do that. And also scale the offset by the actual scale of the instances. So instance scale, there we go. We do all that, we should see. Yep, that all these are no longer colliding with the floor. They're just nicely placed onto the floor. Very nice. But that's good. That's something that we just would not be able to do efficiently in the previous versions, because before you would have calculating the bounds would be such a pain in the buttocks. Now it is trivial and very efficient. Let's see, are those floating? No, they're not floating. It's just because there's one vertice there. It looks like they're floating just a little bit. That's okay. They're technically not floating. They're making perfect contact. Let's see. Hello, thank you for the Tron tutorial. Oh, I'm glad you enjoyed it. I do need to mention that I don't really make tutorials anymore. I don't really have the bandwidth for that because I'm mainly a R&D type Blender user. I'm just like, how would we do this? Let's go and work on this. My workflows constantly update, so it's like, oh, I don't feel confident making a tutorial with something that I just learned in a sense. But I'm glad you enjoyed it, that many people were asking for, or many people were interested in how I made that effect. So the live stream was already there, so I just had to say, hey, the entire creation process of that effect is up on my YouTube channel, and they were very happy about that. Let's see. Hello, I have finished the Blender Guru Donut tutorial, and he recommended your channel. Interesting. How do I start learning nodes? Well, the main thing I would recommend is the shader editor, because the shader editor is where a lot of the vector math nodes can reside. So please bear with me while I do a little, how to get into nodes, basically how I learned nodes. Now this may take a quick second for Eevee to load up from scratch, just because this is the daily build, and the daily build apparently needs to constantly read. Is that the correct sun placement? Oh, it actually is. How about that? I'm going to turn on ray tracing, even though it's not strictly necessary. Or, in this case, screen tracing. Let's go and make this just a little fancy, because yeah, there we go. So, to learn nodes, how would you do that? Let me go and uncheck this. So here, let's start out with a basic UV map. You probably know what a UV map is from the donut tutorial, but there are many things that you can do with this data using the vector math nodes. Now, this is your best friend when it comes to learning more in-depth node stuff. So here we can see with this node, it goes and moves the UV map because you're adding to the value. And if we put, say, a checker texture, or let's use a noise texture because that is less repeatable. We can see here that it looks like it's moving the texture because in a sense it is, you're adding to it. But then what if you want to do something else like multiply it? Well, here we can see that it's making it scaled. And as we can see here, it's making the light brighter. But there's so much more you can do. There are so many options, which don't get intimidated by this because there's, just take it one step at a time. I would recommend ignoring these ones for now. Those are more advanced and more useful in geometry nodes. But let's take a look at the distance node. So right here, we'll see that at 0, 0, it's dark, and then as you get further away, it gets lighter. This is because it is the distance to the value that's right here. So when you move that, that happens. If you look at the length node, it's just the length from 0, 0. So if you were to use a subtract node before that, you could essentially do the distance node. So we can see right here, that happens. And then what else? There's a scale node, which is just like the multiply one, but it takes in a float or a singular value. For the bottom part right here, we can see that that works out just fine. But let's try some other things. Like there is the, let's see, what's another good one? There is the absolute vector math node, which if we do this, we can see that it looks like it mirrors the gradient. But in reality, what it's doing, and I recommend Googling all these, like that'll help a ton when you're learning. But we can see here that the negative values are just turned into positive. But yeah. And then there's all kinds of things, like we can use the modulo, and we can see that that kind of makes the values repeat after a certain point, as we specify here. There's fraction, which also does that, but in increments of 1. And then, yeah, there's max, which means choose the maximum of these two values. So here, let's see. It's a little hard to see there, but when in doubt, just Google vector math maximum and it'll tell you what it's actually doing, and that can be very, very helpful. But yeah, little intro to vector math right there. Just a ton of useful things just for handling vector data. My personal favorite, which one is my personal favorite? I think either the cross product or the dot product, because they're so useful in many situations. But that's a story for another time. That's for like the more technical stuff. Okay. Can the instance bounds node be used to avoid intersections between instances in some way? To an extent, but it gives the building blocks for that. So if you have the bounding box of a node, you now know just how big that node is, which is useful for collisions, as we can see here. But for finding out like collisions in between nodes, that can still be a bit iffy. But that's just because collisions in geometry nodes are still fairly difficult to do. But this will allow you to do it much more efficiently. So, for example, if you were to go and get the, what would it be? The distance? Would you want the distance between these two? Yeah, let's just go and do that. It won't be entirely accurate, but what the heck. This would give you like the radius of each instance in a sense. Now, or kind of, but you know what I mean. This will give you like the distance, and then you can use that for like collisions if you use like the index of nearest and all that. So in theory, yes, but it's mainly, I'm hesitant to say that just because collisions with geometry nodes are still kind of annoying to do. We don't have a general like collision points node, even though I think someone might have proposed something like that in the past. Let's do a little test with that. So this can be used to get collision data efficiently, according to the bounding box. But it's just a matter of actually doing the collisions that can be a little iffy. And for the newer user in the chat, my live streams are usually pretty advanced. So if you're intimidated by what you see on here, don't worry. It's advanced stuff. So don't worry about it too much if it's overwhelming. So here we can just subtract the neighbor's position by this one. And then we can, let's see. We also need to get the distance from the other one. Or the size. So again, collisions are just annoying. That's just something that... It is what it is. But yeah, let's go and subtract that by that. So normalize. I'm doing a very, like, quick collision setup. So in theory, I may need to scale that by -1. We should see that these... Oh! How about that? I think that's because that's... Oh, and that no, that needs to be instance, and that needs to be instance, right? Right, so we should see, if I set this to like -1, they're at least trying to avoid each other. They're trying. Actually, wait. I probably did this wrong. No, I'm supposed to add. So that here. Let's see. Yeah, we can see that these are at least trying to actually, We get the vector, we get the distance, and Wait a minute. No, we are supposed to subtract that. And then, get the max of 0 so that it doesn't go beyond where it's supposed to. We do that and then set that to be that. Yeah, we can see that the ones that are colliding are trying to move away, but again, collisions are just annoying to set up. And off the top of my head, I forget the exact way. Okay, let's read the chat once again. I completely understand, but I'm grateful you did. It's an advanced tutorial for me, but it helped me a lot. I have the motivation of a 14-year-old to explore everything again. Thank you. Hey, I'm glad. As a formerly 14-year-old Blender enthusiast, like, I think that's when I kind of started my Blender journey. I was like, ooh, what's this? What's this? There's something everywhere. But, yeah, I'm glad I could inspire that motivation. Like, back then, back in the olden days of, what was it, like, 2016, geometry nodes did not exist. We only had the modifier stack. Geometry nodes became a thing in like 2019, 2020, I believe. Maybe even later. Oh yeah, maybe it was 2021 when the first iteration came out. But yeah, now we have much better tools than we had back then. So we can do so much more. Let's see. I'm happy that you got this node into the new upcoming Blender release, as it would solve the merge by distance method to find the middle of the instance I'm working with, which is also slower. Yeah, merge by distance, that's interesting. I haven't seen... Oh, okay. Let's go back temporarily to the test file, so let's be right back. There is a better method than merge by distance in order to find the midpoint of that, so if you're still working in old versions of Blender, it's always good to know the alternatives, because you'll never know what kind of project for a client or something like that needs to be done in an older version. But this is how you get the min and max with the old method. You turn the instances to bounding boxes, and then you read the data from that box, and then you put it back onto the instance domain. So that's how you do it in the old version. Again, this is to avoid workarounds. That's the main thing that I've been trying to do with the nodes I'm trying to implement. Just avoiding workarounds. Let's see. Hello, I like your streams. Ah, thank you. I am glad. I hope they are informative. 2 more questions. 1, is it possible to create a simulation like cloth in nodes? Technically yes, but collisions are always a pain. I would recommend just using Blender's inbuilt cloth simulation, just because it's existed for probably a decade and a half at this point. So just use that for now. Collisions are always just annoying to do, but you can do many things in simulation nodes, but there's already an inbuilt system, so just use that. Pixel art with or without dithering using nodes. Oh yeah, there are tons of ways to make like dither-based shaders and stuff like that, or just pixel art in general in Blender. I would recommend just looking up tutorials for that, because there are many, like, when Spider-Verse came out, there were tons and tons of tutorials on how to do that kind of dithering effect. So I would recommend looking up those. But yeah. You learn something new every day, thanks. Yeah, I'm glad. Now I'm 40, so it hits a little harder. Oh, wow. I find it very encouraging that people that are older than me are learning from my work. It's very validating. I'm glad I can help in your Blender learning journey, even though like you've probably seen many 3D programs come and go. So I'm interested to hear like what makes Blender special out of the bunch. Like the reason I started using Blender was because, well, I was a child and Blender was free, so it was a pretty much a no-brainer. Just, oh, let's use this cool program that I can get for free. Like, open source is very different than just like, oh, free stuff. But back then, as a kid, I was just like, oh, free stuff. And now, quite a few years later, I'm contributing to the code, which is very nice. What can we do by learning geometry nodes? so many things. So many things. Like, for those of you who don't know, there was a nice little movie called Sonic 3 that uses geometry nodes for some of the effects. So, if you want to know if geometry nodes can be industry standard, I have the answer. It's like, yes, it can be used in those kinds of productions, given that the pipeline supports it. And also Sonic 2, and a little bit of the Knuckles TV show. But yes. Sonic 3. It got beat by the Minecraft movie financially, and I'm a little annoyed by that. We lost a chicken jockey. Anyway, funny little side note aside. Yeah. Let's see. Love the stream? Hey, I'm glad. Need to watch this again to understand the use cases of the instance bounds node. Yeah, it's mainly just for efficient ways of getting, like, the actual size of the instance. Because in reality, instances, if we use the instances to points node, we can see an instance's true nature, and it's just like, oh, it's a dot. Though, with instances, they are much more complicated than that, but usually, when Blender is dealing with it, they just see a point with data. They don't usually see the underlying, like, mesh, unless you realize the instances. And under the hood, this node, it goes and finds the real geometry and then gets the data from that, which it being coded versus nodes makes it much more efficient, and it's only looking at the unique geometry sets instead of every single one like the old workaround. And there were talks about, like, for each instance geometry set zone, which could potentially do something like this and more in the future, just by getting data from the instance geometry and then putting it onto the instance quote-unquote point as well. But that is in the future. But a low, a node with a very specific and shallow, a very specific scope like this was could be incorporated into Blender's workflow, which is why it was accepted. Let's see. Let's read the chat once again. I think I'm pretty much caught up. I want to learn some 3D hard surface. I want to become a 3D hard surface artist. So is Geonode. Sorry. It's a little bit late over here. Well, no, it's not too late, but I'm a little bit tired, so my words are slipping up a little bit. 3D hard surface, does geometry node help this? Geometry nodes can, but with hard surface stuff, you're mainly using booleans and sculpting, and there are many tutorials for hard surface stuff. And there's also, like, if you want to do hard surface stuff, you know, CAD is always like just a better option for that, because every single product that's pretty much made is done in CAD. Like, the chair I'm currently sitting in was probably designed in a CAD program. My phone, my monitors, my PC, probably my desk even. And those were most likely not modeled using polygons. They were most likely done in CAD software because they use special math, and the booleans are perfect. Unlike with triangulated booleans in Blender, they can fail so often. But plasticity is a good modeling program for that, even though it's relatively new. I remember using that, and it was the alpha, I believe, and that was pretty good. But there's also, like, free CAD and stuff like that. I do need to do more CAD stuff in the future, but yeah, that's for when I get bored of geometry nodes, which it's been, I don't know, like 4 years so far, and I haven't gotten bored yet. Let's see. I actually used GeoNodes to help my workflow when I was working on that piece-by-piece Lego movie. Oh, cool! So it definitely can be seen as industry standard, yes. That is very interesting to hear. Like, in terms of Blender being used in cinematic, like, in the movies, like, Spider-Verse comes into play, like that Lego segment in there was done by someone who uses Blender, and I believe he was 14 when he did that, so that's a big, like, whoa, okay. So there are very many very talented kids in the Blender community. And then, well, of course, Sonic 3 got a good, that was very fun, very, very fun. And then apparently Piece by Piece, Flow, the Oscar-winning movie, was done entirely in Blender and Eevee without compositing, which, like, that I find incredible. Like, my workflow is usually Eevee Legacy without compositing or very little compositing. So seeing that an Oscar-winning movie could do that, I'm just like, whoa, okay. Very, very incredible. But yeah, Blender is being adopted more and more often. It's just highly dependent on which studios, like, if you're working on something like, oh, there are 100 characters that are like 3 million polygons each, Blender probably won't be used. They'll probably be using like inbuilt tools for like Maya or Houdini, you know. Houdini's always king when it comes to procedural stuff in the industry. But Geometry Nodes is helping Blender become a bit more versatile in that space. But like if you want to do like cinematic level effects for movies and TV shows, Houdini is the current industry standard and probably will for the rest of eternity. Again, Geometry Nodes is amazing, but you know, when people are like, oh, this will go and take over Houdini, it's like, no. Houdini is a specialized tool for a specialized situation. Geometry Nodes, while helping with a lot of Blender stuff, it's to make Blender better, not to detract from Houdini. Let's see. I started in Unreal Editor because real-time render on my old GTX 960M worked at least a little bit faster, but Blender can do nicer and better effects for short animations, and I forced myself to learn. Oh, very interesting. How to optimize the scene and make it look much better. Oh, sorry, those were 2 comments. I forced myself to learn how to optimize the scene and make it look better, but it's only 3 months and I still have a long way to go. Yeah. Like, yeah, just keep going. Like, Unreal, I do a little bit of Unreal. And, Unreal is extremely powerful. The only downside is that just, it's so heavy all the time. So I do just prefer Blender because it's light. But yeah, Unreal is incredibly powerful. Have you tried to speed up the build times of Blender using Ninja and Ccache? I haven't tried it yet, but I saw it in the docs. No. And I really should, because the developers pointed me towards that a little while ago. And I just haven't gotten around to it. Usually when I build Blender, I just put in make light and then run it. And then that usually takes, like, if it's building from, like, a new pull, that takes, like, maybe around 10 minutes. But if you just updated a file and then run it, it'll do it in, like, 2. So it's not too bad, but I definitely should, yeah. They recommend Make Light Ninja, I believe. I think. Or Make Ninja Light. I forget the order. Yeah. Let's see. Oh, sorry that I haven't been just doing more instance-bound stuff, but the chat has been quite nice today. Here's a little example of... Let's see, what was this again? Oh, right, the grid. Okay, right. Let's go and take a look at this. So this example here was a test to see if it could be used for... Uh-oh. That's why it was lagging. I see. Attribute text. Rendering text, especially like millions of them, could be a little bit daunting. So this test was to see if I could make like collision detection with another mesh using the instance bounds. So in this case, we store the instance bounds, we make the instance's points, we sample the nearest point, even though, oh right, we can't sample the nearest instance, so that's why that was done. Then we do that, and also transform the instance bounds by the instance transform, yada yada. But we can see that that works. I think there are some situations where it fails. Yeah, like right there, that one's not being detected. But I don't know, it is, but it's just being a little... Oh, maybe that's because... No, that's relative. Oh well. But we can see that, yeah. Maybe I needed to invert that. But yeah, that's like for basic collision detection, but, you know, Bounding box collision. It's not axis aligned bounding boxes, by the way. It's just regular bounding boxes, which may or may not be more accurate. Probably less accurate if I had to guess. Is AI taking the job of 3D artists? Maybe for like NFTs. Like, I am so incredibly happy that NFTs and AI stuff did not appear at the same time, because that would have been hell for 3D artists. But I'd say at the moment it's not too bad. Like, I'm sure freelancers are feeling it just because more people who want to get stuff done fast are just going to like AI people for that and not actually trying to get it done by 3D artists. So it is becoming worse, but I'd say that 3D artists are pretty okay for a few more years. Like, if there's a movie industry, there's going to be a 3D art industry for that. With games, you can't AI high quality 3D models. So, yeah. And I guess worst case scenario, we all become like retopologers for AI generated models because, you know, the topology on that is not going to be good whatsoever. But I'd say we're safe for at least a few more years. Yeah. Actually making stuff. Like, again, I've tried the AI stuff and I just felt empty inside, you know? Because if I didn't make it, it's just like, well, I'm just clicking a button and like refreshing Google, essentially. I like making art 3D and 2D, so there's still purpose in making it, even if some people try to take the McDonald's route, just order a art piece from McDonald's. Yeah. I still want to make stuff. Have you oh, I already read that. I hope Geometry Nodes gets as good as Houdini, so there's some competition. Yeah, I hope for that as well. Like, again, Geometry Nodes can do a lot. Like, there have been quite a few Intagma tutorials that I've just translated into Geometry Nodes, and it's becoming a lot easier to do that. Like, what was it? Let's go and... I was actually working on this yesterday. File, open recent. The mesh folding. Well, I have modified it a lot. Let me make this a little bit faster. I'll switch back to the camera in a moment. So this project was a kind of... Let's get the EV Next working. Was a mesh folding effect. It is going to be laggy just because, like, there are a lot of faces right here and edge split is happening every single frame, which is less than ideal. Ideally, like, I would throw in a bake node, but we can't access that in the modifier UI, so... Oh well. So I would just do that, and then this should run... Oh, it's not running in real time. Maybe turn off... there we go. Okay. So here we can see that it's unfolding. Originally, this was an Intagma tutorial using Vex, I believe, in Houdini, the Vex scripting stuff. But in Geometry Nodes, it feels a little bit simpler to do, just because we have some building block nodes like, getting the parent face corner and stuff like that. And then I've recently updated it, not the one that's up on Gumroad, just because under the hood, like, if it works the same, it works the same, it's completely fine. But I updated this one to use the matrix now, which just simplifies the under the hood stuff. And it's just a lot even simpler now. The most complicated part is getting the gradient that is kind of like normalized and stuff like that. And stacking the face transforms isn't too bad. I could organize it a bit better. But yeah. Geometry Nodes can do a lot, and it's going to be able to do a lot more. The biggest thing, like, the biggest difference between Blender and Houdini right now is just the simulation side. Because, like, how do you... Like, cloth simulation, fire simulation, smoke simulation, water simulation, all the simulations, rigid body simulations. Geometry nodes just can't do that kind of stuff yet. Not well. Because getting collisions are just, it's so incredibly difficult to get that running right, especially if you're not using a library like Bullet or something like that under the hood. That may change in the future, like hair simulation is currently being worked on, but I think that's kind of planned for 4.5, or no, 5.0, which is an update after 4.5. Now I've made a little, actually, yeah, we can take a look at that as well. So the instance bounds review is currently done. So we're just going to take a look at other stuff I've worked on, just because the conversation is just flowing so incredibly well. Just loading up another project. Let me make sure that this is not using the build that I had. Here we are. So this is a little hair simulation setup. Ignore that the horse has very long fur. But yeah, here we can see it with all the hairs right there. So we can see that the first simulation is occurring. The only issue is that the collision with meshes is not working as well. And the length constraint is a little bit iffy, just because like we don't have an inbuilt node for that. So this is the setup for that. Again, with making physics stuff, you need to build it yourself. There's nothing inbuilt just yet, but I am working on some stuff that may eventually be good enough in the future. You can see that the constraint, I'm not running enough steps. Yeah. I wish they would expedite work on an expression node. Some setups could condense 50 math nodes into 1 to 2 expression nodes. Sorry about my mispronunciations. It makes node graphs look unnecessarily complex. The expression node. There have been, I think, like 3 attempts at making that, and none of them have gone through. I think it's mainly just because syntax, like what kind of syntax are they going to use and yada yada. Well, I would very much like that. I highly doubt that we'll get an expression node anytime soon. And it would have to be made by the developers themselves, because the times that people have tried to, like, people from the community have tried to make it, every time it's just failed. But yeah, well, it could optimize a lot, I think. It would help. It would help, but it's not a showstopper for many things. And there are add-ons to, like, convert math expressions to nodes, which I would recommend. But again, like with add-ons usually feel like a band-aid in those kinds of situations. So while I would like a math expression node, I wouldn't expect it anytime soon. Let's see. The colors and textures remind me of Marathon. It's not my type of game, but the art style just tickles my brain. Yes, that was a friend showed me the Marathon trailer, and I was like, ooh, that looks cool. So it's just like, oh, let me just try a little something. I do want with that project here, let's go back to that, because first simulation is over. So last week. But yeah, the Marathon trailer was very interesting. I don't really play those types of games, but the art direction was impeccable. Let's go and reverse the folding. So what they had in there was like a cybernetic body being woven and made by, there was like mechanical silkworms and stuff like that, which is incredible. But in this case, I was just like, oh, I have a mesh folding thing. Let's go and try that. So, yeah, that's what I did here. But it looks cool, right? And then for the texture, it's just a magic texture. Just making the little bumps there. Yeah. Actually, what did I... Oh, okay, it is just that. Oh, this is something that I need to look into more. The filter width for that. let's actually go and take a look at that right now. So that's something else that's new in Blender 4.5 that I did not work on. I didn't know it was coming along, but I just saw that and I was like, ooh. Let's go and use a UV map right here. Let's set it to be 2 dimensions. Let's use the bump node. And let's see how this changes with the filter width. And we want that to be there, not there. Muscle memory. I think I saw someone using this as like a pseudo bevel node. Oh, but it's recalculating every single time. Might be a little bit difficult to see the difference. So that was 0.1 before. So we can see that it seems to kind of like smooth out the normal map, which I assume this is just like to get a bump map from a height map, you go and take the difference between 2 other texture samples. 3? No, it should be 2 because, yeah, 2 dimensions. And then I'm assuming this is just like the distance between that, which means that this also, yeah, is affected by the distance from the camera. So it's not like changing the texture. That would be something different. Like the texture nodes, the texture editor, which as far as I know is no one actually uses. It's kind of a legacy thing. But if there ever was like a substance designer part of Blender, it would be in there. Again, that thing is basically legacy. But yeah, if we turn that up even more, we can see that it just looks a bit more beveled, which could lead to some cool effects. Let's go and take a look at it. And not use the viewer part right there. Interesting. Again, let's go and do a nice comparison. Also, Eevee Next feels a lot faster. Actually, wait, does it... Sorry, one second, I need to check. Is Vulkan being used under the hood now? Because this is a lot faster than I usually experience. Odd is using the Vulkan backend. Okay, instead of OpenGL. I thought Eevee Next, even with the Vulkan backend, didn't have a performance increase. But it feels like there is. Well, I won't say no to Eevee Next being faster. Because that was something that I would often have problems with compared to Eevee Legacy, the compilation times. Yeah. But yeah, that's that. So, let's end the stream soon because we're getting up to an hour. So let's go back to the instance bounds node. Again, the reason for this entire stream. So again, this node is now in the daily build of Blender 4.5. I recommend trying it out. Like, it should be bug-free now. Like, the amount of bugs that had to be squashed with it was much more than I anticipated. I thought, like, my thought process going into making this node was, okay, let me go and get the bounding box node. So under the hood, it goes and converts instances to bounding boxes, but it doesn't output the data. So let me go and just switch that so that it does output it. And then that led to a long and branching trail of me finding out why the bounding box node doesn't output that. Like, with this node, I know why. It's because it makes a bounding box for the realized geometry and the instances. So you can't output the min and max for both. But adapting that to work with fields was very, very complicated. Because of, like, the selection mask and all that fun stuff. And also multi-threading, which this is multi-threaded. So it was a long process. And when I say long, I mean it was like a week of back and forth. But it was I thought this node was going to be smaller in scope, but for someone who does not know the field process, it was a lot more involved than I thought. Okay, let's read the chat once again. I've started using Blender since 2.8 by coincidence, and I gotta say that it feels like a completely different program. Geometry nodes is such a game changer. Yes, it is. Like, I would not have my current career if it were not for geometry nodes. Like, again, geometry nodes allows for so much more. Like, how would you instance, like, something as simple as instancing a collection and then moving those instances? You just straight up could not do. in before geometry nodes came around. Not like this. Like, the only alternative would be like animation nodes, and yeah. But geometry nodes, like making a radial array modifier, you can do that now. You couldn't do that before, or I guess you kind of could with empties, but it was a pain to set that up correctly. But yeah, geometry nodes is one of the best things to happen for my workflow with Blender, and it's made upgrades in shader nodes as well. So that's good. Like subpanels, I believe were motivated by geometry nodes, I think. Panels and subpanels. I could be wrong about that though. Could be wrong about that. But yeah, and then like the integer sockets, and then the, oh, when the NPR branch comes out, the zones. Geometry nodes has had a very beneficial impact on everything in Blender. Also, don't forget, there are the import nodes. So importing CSV files natively is very nice. And then, yeah, there's all the rest of these. And you can just import text if you want, which is very, very nice. I remember when they were discussing that in the meetings, they were like, this is just a little node. Should we put it in? Yeah, why not? Yeah. Do you think that with this, the growth rate will start to become standard in many fields? As someone who has used geometry nodes in several professional production environments, yeah, geometry nodes has opened the door for Blender being used in many other industries, many other like pipelines. So it is very good. It has made incorporating it into workflows much, much easier and just better. But there, you know, there's still always room to go in terms of like compatibility and stuff like that. Like USDs, importing USDs is very nice. Importing Alembics, I don't think has all the attributes yet. Maybe they've updated that. I'll need to check 4.5. But geometry nodes and just having generalized attributes now, where you can just store any data on there, oh, it's so nice. Amazing. Like all the Houdini data, like, oh, quaternions, 4x4 matrices. I forget, wait. Does Houdini have 3x3? I'm assuming Houdini does have 3x3 matrices. I would need to double check that. Blender does not have, at least exposed 3x3 matrices. They just usually go with quaternions. But yeah. Now, just importing and exporting stuff from into Blender is just so much better because of geometry nodes and just general development. Yes, Houdini does. Ah, okay, that makes sense. Like with geometry nodes, like we have like all of all this data, but in Houdini, if I remember correctly, maybe I'm thinking about this wrong, or maybe that was Unreal. It would have like float 2, which would be vector 2, float 3, which would be a vector, and then like the matrix, you can just pick whatever kind you want. But yeah, in Blender, like we don't select those in that way, and we don't really need to at this time. Like I do kind of foresee a future where we just have like the float-based ones in one column, the matrices in another column, and stuff like that. But for now, this list is pretty solid for all the things we need to do. 4x4 matrices were like the last main big one, and now we got them, which is very nice. Let's see. Happy to hear your node made it into the next update. You know, I'm very happy that it got accepted and that the devs helped. They helped so much. I'm so grateful for them. They are great. They are very great. Yep. But that is the new node. Again, simplifying previous workflows and workarounds into a nice little node that is extremely efficient. Yeah. New stuff. So 2 down and 1 to go. As we can see here. 2 down. So yeah, Blender 4.5 is looking very, very good with all the other, like we're getting quite a few nodes. Actually, let me take a look at the Blender 4.5 changelog. Here we go. And by the way, Blender 4.5 is an LTS release, a long-term support release, which is very, very good. Okay, let's see all the changes. Actually, can I stream this real quick? Let's see. I'll try to stream my monitor, or my browser. Here we go. So for the last little leg of this part right here, now this may not be up to date given that the instance bounds node was added to the daily build today, or technically yesterday. The mesh to curve node has a new face option, which is very nice. Visual geometry. Oh yeah, this one's big for like games and stuff. Just like turning instances and stuff like that into objects, which is great. Also, the instance bounds node can probably help a little bit with that. Instance geometries created by the string to curves node now have given names. Oh, that's good. The bounding box node now has an option whether to include the radius. That was also put into the instance bounds node. I just copied that code and it was very nice and very convenient. Image inputs. Oh yeah, right. Let's see. Will this show? Let's go to the PR in this case. We can see that right here. Yeah, now it has the new and open ones, which is very appreciated. Let's see, match, camera info node. Oh, look at this. I wonder who, made this one. A little Cartesian caramel. With help from the developers, because the dependency graph stuff was a pain to work with. Yeah, that one is very nice. Camera culling is now viable, which I'm very happy about. The attribute statistics node. Oh, wait, the field statistics nodes made by Quackaroony. Some very handy nodes for basically not having to use the attribute statistic node, having it be compatible with like group ID and stuff like that. Very nice, very, very good. Oh, and those are merged now, so I should actually try those out. The viewer node supports the hotkeys, the shortcuts. The instance bounce, oh, that was added. Very nice. Yep, two down. Oh, and link and drag search now supports adding zones. Now this one is pretty cool. Because now you can drag and then add in like a repeat zone, which is very nice. I wanted to do that quite a few times. But yes, it's very good that that's now a thing. The mesh normals, we can now set the mesh normal node, which people have been wanting for quite a long time. And now it's implemented. Before we would have to use the data transfer modifier, which is a little bit limited in some cases. And then the import nodes, which I'm so excited for these because it's just, again, communication between geometry nodes and other parts of Blender and just the world. Getting data into geometry nodes is essential. And the goal with like the camera info node was to just help with that. And then with these, just getting more and more data. Like the CSV node, very nice, PLY, STL, OBJ, and then just plain text. I'm so glad that we have a plain text option. Because like that allows us to make our own parsers for stuff like that, which is very, very nice. But yes, that is Blender 4.5 is looking very, 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 very good. And I'm very excited about it. Let's see. But yeah, that is everything for today. So, new nodes coming in Blender 4.5. Yeah, I hope you all enjoyed this little live stream. And yeah, I'll see you next time. Have a good one.